Okay, let's go ahead and start the Jupyter Notebook. Today's class will be probably a little bit shorter. I just have a couple more core concepts that I want to cover in basic Python before we move. Next week, we'll start talking about NumPy, and then we'll start talking about Matplotlib and the other scientific and artificial intelligence coding toolkits. So for this week, we just need to cover the rest of the basic material having to do with the Python programming language. So go ahead and start the Jupyter Notebook and open up to Lecture 4, and let's take a look at this. The only core concepts that I want to talk about today are dictionaries, functions, and modules. Modules are files that contain programs. Functions are individual functions that you can call from those modules, and dictionaries are the only data type that we haven't talked about yet. So in particular, so a dictionary is really the key idea of a dictionary is that it's exactly like a list, except that instead of being indexed by integers, you can use anything as the index. Let me increase the size of the font on this. There we go. That's a little bit better. A dictionary is like a list, except that instead of being indexed by integers, you can use anything as the index. So it's initialized in a different way. Rather than you remember that a list is initialized, we can initialize the list. List one equals 1, 2, 3. Let's say 4 to 49 A, and then let's print list one. And I'll include this character means new line, \n. And now let me also print dict1 is, and then I'll list the dictionary, and then I'll include a \n for a new line. And then let's print the 0th element of dict1 is, and then we'll print the 0th element, and then we'll print a new line. And then let's print the sum key element of dict1 is, and then we'll print the sum key element of dict1. So you see list one is just a list, right? It's a list of elements 4 to 49A. It's a sequence of elements that are all in order. A tuple is also a sequence of elements in order, but a tuple is unchangeable. A list is changeable. But in this case, the 0th element of a list is, let me add the 0th element of the list as well. There we go. So list one is 4 to 49A, and the 0th element of list one is the number 4. Right? So these elements are just indexed in order, 0, 1, 2, 3. There are 4 elements in the list, and their indexes are 0, 1, 2, and 3. A dictionary is indexed by whatever you want to index it by. So the dictionary contains a 0th element called this is value number 0, right? So we can see that this is the string. This is value number 0. But a dictionary also includes an element that's indexed by the string some key. So here I have dict1 of some key, and the element that's indexed by the string some key is the number 35. So in a dictionary, you don't have to index by integers. You can index by strings or by tuples or by real numbers or by almost anything. A dictionary has any sequence of keys and a corresponding values. It, its, its syntax looks very much like a list. Notice that we have dict1 of 0, just like we have list1 of 0. But here we have dict1 of some key, and we can't do that with a list. If I try to index the some key element of the list, then it will give me an error. Let me move the dictionary first, and then let me try to access the some key element of the index, and notice that it says list indices must be integers or slices, not strings. So it's perfectly okay to use a string as the index into a dictionary, but it's not okay to use a string as the index into a list. And that's the main difference. Otherwise, they behave almost exactly the same, right? That means that there's no idea of a sequence in a dictionary. There's no real idea that this element comes before this element. Whereas here, clearly, element number 4 comes the element number 0 comes before element number 1. Here, this element doesn't really come before this element because they are each indexed by some arbitrary key. All right. Dictionaries are most useful when you access them using a variety of methods. And in particular, dict1 keys returns an iterable element with the sequence of all of the keys in the dictionary. And if I enumerate it, then I can get those keys as if it were a list, right? So I can return, this does for nk and enumerate dict1 keys, and it will list the key number n is k. And notice that now we have these two elements. Key number 0 is 0, key number 1 is some key. And this will return these elements in pretty much arbitrary order. In this case, it returned them 0 and then some key. These are the two keys of this dictionary. The dictionary also has some values, and the values are, this is value number 0 is the first value, and 35 is the second value. Notice that the keys and the values are returned in the same order, but that order is arbitrary. It might be reshuffled inside the program. So every time that you call dict1 values, it will return an iterator that has the entire sequence in order, but the order might change from one time to the next. When you enter a new element in the dictionary, the order might change. Often you want to get both the keys and the values, and you can do that using dict1 items. What this does is it returns a tuple. So you can see that the dictionary that is now returned a tuple where the first element of the tuple is the key and the second element is the value. So that's a dictionary. A dictionary is basically a list, but instead of just using integers as the index, we can use arbitrary strings as the indexes. The other key concepts that I want to talk about today are functions and modules. Functions are, we have built-in functions and we have self-definable functions. The built-in functions are listed here, and there are a lot of them. ABS, for example, calculates the absolute value of an integer. Bin converts an integer number into a binary string. So bin of 3 is 0b11. That's the binary version of 3. Bin of -10 is negative 0b1010, etc. So it generates a string with the binary element, and so on. All of these are the built-in functions in Python. Set converts an element into a set, float converts it into a floating point number, and so on. All right, so for example, the element input is kind of useful. We can type input, please type a string, and what that does is it puts a prompt on the command line, asks the user to enter a string, and then returns the value of that string. So here, s equals input, please type a string. If I run this code, it will ask me to type a string. And it will then say, print you typed s, and the s is hello, this is me. This is the string that I typed in. So the input function is one example of a useful function. If we go to the built-in functions, we can look up input. Here it is. And input prompt, if the prompt argument is present, it is written to standard output without a trailing new line. The function then reads a line from the input, converts it to a string, and returns the string. Perhaps more useful, and we're going to do this quite a lot, is to define your own functions. We did this last week in the homework, and we'll do it again in this week's homework. So we define our own functions using the keyword def. DEF is short for the English word define. It means create a function. The syntax looks like this. We start with the word def, and then we have the name of the function, and then parentheses, and then the arguments of the function. So here I'm going to define a function called myFirstFunction, and its argument is the prompt string. These three quotation marks mean that I'm going to have a multi-line string. And if I start my function with a string, that string at the very beginning of the function is called a docstring. It's used for documentation. So when I define the function in this way, then I can type help myFirstFunction, and notice it will return all of the information that was in that document string. So this entire string, this doc string, is returned whenever somebody asks for help about your function. So this is even more useful than a comment, right? This is basically a comment about the function, but instead of a comment, this provides extra information that allows you to describe the content of the string in a way that people can get to it while they're using the function. They don't have to go and read the source code. Like the if statements and the loop statements from last week, everything is indented, right? Every line inside the function is indented by four spaces, right? So these three lines are part of the function definition. This line is not part of the function definition because it's not indented. So the function does the following steps. It uses the input function to ask the user for some input, and then it prints out a blank line, and then it prints out you typed, and then the input that the user typed. So now if I run this code, notice that it runs this line. Print this line is not part of the function definition. That happens. But it doesn't run any of the content of the function. We haven't actually run the function yet. We've only defined it. If we want to actually run it, then we call the name of the function followed by something that we want to use as the argument. So here, please type something, and then I'll write something. And it says, you typed something. Or I might, let's change the prompt string. All right, so now it noticed that myFirstFunction was called with the prompt string prompt and it asked me for input, and here I am typing a string, and I'll hit return, and it says, you typed, here I am typing a string. Notice that here, all I did was type the word myFirstFunction, and that called all of this content. It asked me for input, it generated this prompt string, it collected the return value from that function, and then it printed out that return value with the words you typed. So you can say here, it says, you typed, here I am typing a string. So by defining a function this way, we collect a bundle of code that we want to be able to run over and over again at any time in the future. In Python, the only difference between a function that has no return value and a function that has a return value is whether or not the function contains the keyword return. So if the function contains this keyword return, then the function will return that value. Let me double the string. Let's say that I'm going to take this string s and I'm going to double it. So now let me define my second function, and now let me run it. Please type something, and I'll type the word hello. And when I hit return, nothing happens because I haven't yet printed out that content. I've just returned it. Notice that I've returned it as the variable x. And so here, if I print the variable x, it will say, hello, hello. So notice what happened. Inside the definition of my second function, I took that string, the word hello, and I doubled it, right? I multiplied times 2. So I doubled that string and I returned it as the variable x. Let me type here. Let me type out what the variable x has been set to. So the string x has now been set to Python. So my second function takes this string and it doubles it. And now if I print x at any time in the future, I get the string Python until any time in the future when I might reset that. So the key concepts here are, first of all, you could define a function just using the keyword def. Second, if you want the function to have some return value, you need to include the line return. Let me try calling my first function here. My first function, notice it has no return line. And so what's going to happen when I try to assign the return value from my first function to x, I'll get that x is set to none. Right? Notice that the string x has now been set to none because there is no return value. And so Python uses this keyword none to mean that there's nothing there. Variable x has nothing inside of it. This is a special, the object none is a special object that means the variable that you've asked for has no value. So if I want that variable to have a value, I need to have a return statement. And let me add a return statement here. Let me add a return statement to my first function. If I add a return statement, now the next time I call my first function, it will actually have a return value. So if here I call my first function and get the return value x, now you see the string x has now been set to hello. So now I've added a return statement to my first function. Now when I call my first function, now it generates a return value. Notice that I don't need to use the return value. Let me just get rid of this. Let me just call my first function. If I call it and I don't use the return value, then that return value is just generated as the output of the function, but it's not assigned to any variable. It's just generated as the output of the function. I think x is still hello. There we go. All right, so now we know lists and tuples. We know if statements, we know loops. Now we know dictionaries, and now we know functions. Those are the main concepts in Python. We also know real numbers, integers, Booleans, and we know strings. I just want one more concept, and that is the concept of a module. A module can be a function that we define for ourselves. So for example, homework4.py is a module. This is a file, and we're going to edit this file. And any file is also a module. But we can also import arbitrary functions. So there are modules, there's a list of modules in the standard library. The Python standard library includes these built-in functions. Let's see. Where are the built-in modules? Well, and for example, Anaconda includes a list of modules that are shown here, neural networks, et cetera, et cetera. So PyCharm, Visual Studio. I'm not getting a good list of modules anywhere. So PyPy has a set of modules. Well, one of the ones that we'll use often is math. Let's find Python math. I'll just look for Python math module. And here's the documentation for math. So math contains mathematical functions, including combinatorics, factorial, greatest common divisor, integer square root, least common multiple, and so on. So this is an example of the math functions. Python also has numbers classes, CMath, which is math for complex numbers, and many other modules. So for example, if I import the math module, then I can take the cosine of pi over 6. The math module includes a definition of pi. So here's constants pi and e and tau and infinity and not a number. It also includes things like the cosine and the sine and the tangent. And generally, in this class, I'm going to keep the name of the module. So if I want to call the cosine function, I'm going to specify which module I'm calling it from. And the reason for that is that in Python, there are many different definitions of the cosine. There's the definition in the math module, and there's the definition in NumPy. And those definitions differ in the precision of the function. In the math module, the cosine is calculated with 4 bytes of precision. In NumPy, it's calculated with 8 bytes of precision. And so depending on which module you use, you get a different amount of precision. But we can use the math.cosine, for example, by just typing math.cosine of math.pi over 6, and we find that the cosine of pi over 6 is 0.866. If you want to make sure that it's doing what you want, then you might want to take the cosine of pi over 3. As you know, the cosine of pi over 3 is 0.5. Or you could take the cosine of 0. The cosine of 0 should be 1. Or we could take the cosine of pi. The cosine of pi should be -1. Or we could take the cosine of pi over 2. The cosine of pi over 2 should be 0. And you can see that it's actually 0. It's 6 times 10 to the -17th, which is basically 0. So the additional basic concepts that we've covered today include modules, dictionaries, and functions. And now let's use all of them. Notice that I'm going to import the import_lib module. Let's look that up. Python import_lib module. Here's the implementation of import. The purpose of import_lib is to allow us to do things like reload. Here we go. Import_lib reload reloads a module that you've previously loaded. And I told you last time that this is necessary every time you change the function. So I'm going to import the homework4 module, and then I'm going to reload the homework4 module. And this is necessary because if I don't tell it specifically to reload, then when I call import homework4, it will first check to see if it's already loaded it. And if it has already loaded it, then it won't reload it, which means that any changes that I make will not get implemented. It won't keep track. So here I'm going to ask for help on the list to dict function. If I look in homework4, there's just one function, list to dict, which has a parameter equal to the input list, and then this docstring. So it says that this function should return a dictionary in which each element of the list is a value, and the corresponding key is the numerical index of that element in the input list. So if I give it this list, it should return a dictionary in which 0 maps to 1, 1 maps to 3.14, etc. List to dict with an empty list should return an empty dictionary. So if I try running it here, it will give me none, none, none. The reason it gives me none, none, none is because I haven't defined this function to do anything at all yet. So in order for it not to do none, 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 I need to define this function. Let's create an output dictionary, which is empty to begin with. And then let's say for nx in enumerate the list. Let's set the output dict of n equal to the value x. And then we need to return the output dict. So 3 things we need to do. First of all, we need to define the output value. Second, we need to create those entries, right? The key is the numerical index of that element, and that numerical index should map to the value. And then we need to return that dictionary. Let me save this Python file. Let me go back to the homework, and now I'm going to use import_lib reload in order to reload that homework. And now if I run it with this list, I get the desired dictionary as the output. If I run it with this list, I get the desired dictionary as the output. And if I run it with the empty list, I get the desired dictionary as the output. If you want, you can check using the grade.py to make sure that it works. And it says, yes, it ran 2 tests and got 100%. That's actually all for this week. So let's go ahead and upload that to GitHub and then put it into the homework. GitHub desktop. Let's try, I did homework 4. And then let's push it to the origin. Notice that this should be pushing to your own GitHub, not to mine. So if you go to github.com and go to your own account on GitHub, right? If you go to the original account, J Hasegawa, then you'll see something that still looks like this. Lecture 4 will still be, homework 4 will still have a pass. But now if I go to um, if I go to the student account, so this is my student account, and you should each have your own student account. If I go to my own student account and look at homework 4, now it should have the completed assignment. So now I can take this URL and copy it and go to the portal, go to homework 4, and go ahead and copy here your the URL for your own copy of homework4.py. That's all for this week. As I said, this week is somewhat short, so let's go ahead and take attendance, and then we'll be done for this week. Let me see. Attendance is here, I think. Okay, everybody, please go ahead and register your attendance using this code. Thank you. Okay, I think we still have 4 people who haven't registered attendance. I think now we have 2 people who haven't registered attendance, unless I'm mistaken about that. Is there anybody else who has not yet registered their attendance? Okay, thank you, everyone. I'll see you next week, and I will upload the video of this lecture also to the YouTube channel so you can follow it there if you want to. Thanks.
Thank you, Sensei.
Thank you, sir.
Thank you. Have a good week. Bye-bye.